Hello everyone, welcome to today's class. This is Teacher Simon taking you through A-Level Pure Mathematics 3, paper 9709/32 for May, June 2025. And this is part 2. Question 7 is coming from trigonometry. Express 7 sine theta plus 24 cos theta in the form r cos theta minus alpha, where r is greater than 0 and then 0 is ranging from, alpha is ranging from 0 to pi over 2. That is the first quadrant. Give the value of alpha correct to 4 decimal places. Okay, so we have 7 here, sine of theta plus 24 cosine of theta. This one here has to be equal to, we have the 7 here as the coefficient of sine, so I will say 7 square it, then plus the coefficient of cosine here, which is a 24, so I'll put 24 squared, then the cosine of theta minus alpha is actually the arctan of, I've already said, if you have been following me in those videos on this channel, the coefficient of cosine, since I'm expressing this in terms of cosine, then the coefficient of cosine here is the one that goes down here in the arctan, okay? And then the one for sine is the one that goes up here, okay? So we get this one here, square root of 7 squared plus 24 squared. That one gives us a 25. So we have 25 here, then the cosine of theta minus alpha here must be in radians, okay? So our calculator has to be in radians here. It's already in radians, so arctan of 7 out of 24. This one gives us 0.2838. 0.2838. Remember, they said alpha should be to 4 decimal places. So that means this one is going to be our answer. Okay, this one here, to say that the coefficient of cosine, I put it down here. This is where I get it from. Now, what you can do, if you want to waste your time, but when you do this, you get your 3 marks. But you can do this, but you are going to end up with this, okay? Alternatively, you are going to expand. This one here, okay, is equal to the r, then cosine of theta minus what? Alpha. Now, here you are going to have, using compound angles, this will be cosine of theta cos alpha, then plus we have sine of theta, sine of alpha, okay? And then from here, we now equate the what? The coefficients. So you say equating coefficients of first sine theta. So here we are seeing a 7, and then pull out the sine theta, you'll get r what? Sine alpha. So we shall have r sine alpha, which is equal to 7. And then for cosine of theta, we shall have, take this one away, so you have r cos of alpha. So r cos of alpha then is equal to this one, 24. So I have these two equations. This is equation 1, and then this is equation 2. So if I get these two, and I say equation, let's say 1, okay, then I divide by equation 2. So we shall get r sine alpha over r cosine of alpha, then shall be equal to 7 out of 24. R will disappear, and then sine over cosine is a tan, not so. So tan alpha shall be equal to 7 out of 24. So do you see that our alpha is equal to the arctan of 7 out of 24, which is exactly here. You see that the coefficient of cosine, if I'm expressing in terms of cosine, then it is the one that goes below there. You see that? Uh-huh. Then we can also get equation 1, and then we square it. Then we get equation 2, we also square it, and then we add them. Why? Because we know there is a relationship between cosine and sine. So r squared sine squared alpha, then plus r squared cos squared alpha, then this one is equal to, the other one is 7 squared, then plus the 24 squared. R squared here is common. I can factorize it out. So we have sine squared alpha and then cos squared alpha, which is equal to, this one is 49. When you add on the square of 24, you will get 625. Okay. And then we know that this one is equal to 1. Okay. So r squared will be 625. So meaning your r is going to be the square root of 625, which becomes a what? A 25. You see that? Or it is the square root of this, which is what I did here right away. You see that? So when you're finding r, just get the square root of this squared plus this one squared. And then if, let's say we were writing this in terms of sine instead of cosine, then the coefficient of sine here would be the one down, as simple as that. Hence solve this equation here. Okay, now we need to compare. So comparing with 7 sine theta plus 24 cosine of theta, which is actually 25, then cosine of x, cosine of what? Theta minus, so theta, then minus, our alpha is 2838, 0.2838. Okay, this simply implies that if you check, a third of x is the theta, right? So x, theta shall be equal to x over 3. So therefore, this one here is going to be 25, then the cosine of, where there is theta, we put x over 3, then minus 0.2838. A mistake people do here, because theta is equal to x over 3, they also come to this angle and they also divide it by 3. That's very wrong. So this one, then we equate it to 24 point what? 24.5. And then x over 3 minus 0.2838 then shall be equal to the arc cos of 24.5 out of the 25. You see that? All right. Now, this one here, we can see that it is positive. So cosine, we know that it is positive in, and you can see that this one is from 0 to pi. So we are considering the first quadrant and then the second quadrant. So 0, then this will be pi over 2, then this is pi, then this will be 3 pi over 2. Then when we come back here, this is pi. All are positive, on the sine positive, on the tan positive, on the cosine positive. So if I have an angle here, then projected this way, it will also be that, because opposite angles are equal. Same angle here, projected here, will also be that. So that will be pi minus theta. This will be pi plus theta. That is if we are going anti-clockwise, right? And then this is 2 pi minus what? Theta. So going clockwise, anti-clockwise, the angles are positive. And then going clockwise, the angles are negative. You see that? All right. Now, from here, 0.2838. Now, when you see this, what we are going to get from here, when we are getting x, we shall add on this, because we shall take it that side, and then we shall multiply by 3. Okay? So this one is going to be, what is the arc cos here? Calculator in radians, so arc cos of 24.5 out of 25. Then this one is 0.2003. So let me write, since this one is to 4 decimal places the value of alpha, even here let me write to to 4 decimal places 0.2003. This one I can write plus or minus. Why? If I've gotten the answer here, then it is the same as this one here, because cos is positive in the first and fourth quadrant. Okay, you know that cosine of negative theta is equal to cosine of positive theta. You get it? So that's why I'm putting plus or minus, because you can go here anti-clockwise, you fall in the first quadrant where cosine is positive, or you can go here, you go anti-clockwise, you will fall in the quadrant where cosine is positive. Or if you don't go clockwise here, you can still go clockwise, but to get the angle in the fourth quadrant, then you will say 2 pi minus what? Theta. Okay, so instead of using 2 pi minus theta, because I'm given from 0 to pi, I can instead get the what? The negative value of this one here. So I move here and then I move here. Hope you have gotten that. Okay. Now what else? What else do you think we are supposed to get here? Okay. Now from here, I think these ones are enough. I don't need to get this other one, 2 pi minus theta. No, I'm taking the minus here. Okay. All right. So that means our x is going to be equal to, take the positive one. So we shall have 0.2003. You add on the 0.282, 38. Then from there, you multiply it by 3. Take this one here, then multiply by 3 by 3. You get it? Then the next one is going to be the negative. So it will be the whole of this, okay, here. And this one has to be a negative, not so. So we shall have 3 times the negative of this one. So what do we get here and then here? 3 into 0.2003 plus 0.2838. Then I close the brackets. That will be 1.4523. So to 3 significant figures, I'll write 1.45. Okay, then how about this one here? I'll just come to this one and then I make it a negative. Then we get 0.2505. And then this one gave us 1.4523. So to 3 significant figures, I can smartly write my answers from the smallest, 0.251, and then 1.45. 3 significant what? Figures. That is that. Question 8 is coming from differential equations. The variables x and theta satisfy the differential equation. This one here, and x is equal to 0 when theta is equal to pi over 12. Solve the differential equation and obtain an expression for x in terms of theta. So the first thing we do here is to separate variables. Okay, and I've already said that when you are separating variables, you use multiplication, cross multiplication. Okay, so I'll cross multiply here. So this one will simply imply the theta will come up here, let this one come down here, and then you divide all through by sine 2 theta and it will come there. So meaning we are going to have dx out of 4x plus 3. Then this one will be equal to cos of 2 theta, then the theta, but then we shall divide all through by what? Sine 2 theta. Okay, now we do the integration. So integrating. When we integrate, we shall have This one is 4x plus 3 power negative 1, not so? Then dx. Now, actually, I'm not going to write this because if I increase the power by 1, it is going to become a 0, and then I divide all through. You see that? So this one has to be done under the natural logarithms. Pardon me here. Okay, then this one is going to be the integral of, this one is cos over sine, but still I can leave it there, like that. The theta. Now, when you differentiate with respect to x, the 4x plus 3, okay, you will get a 4. But what should I do to this 4 to get a 1? I will divide by 4. In other words, I will multiply by 1 over what? 4. Now, this operation I've done here is the one that I put on the natural log, okay? Remember, we have, if you are integrating and you're seeing that what you have in the numerator is the exact derivative of what you have in the denominator, okay? What you get is the natural log of the denominator. You get that? So this is what I'm going to have. Now, what I will do, this one that is up here, the 1, it is the same as saying it is a quarter, then times the 4, not so, to get the 1 here. But that 4 is the derivative of this one. So I will say dx of 4x plus 3. Then divide by the 4x plus 3. And also, from here, do you also see that the integral, when you differentiate, with respect to theta, sine of 2 theta, you get cosine, okay? Cos 2 theta. Now, if you get cos 2 theta, you will also go inside here, you differentiate the 2 theta, you will get a 2, not so? Now, you can see that we are also getting what is up here. Now, how do I transform this one into this? By multiplying by a half, not so? So this simply implies that I'll have my integration here, like that. Then I say is equal to the integration of, remember I'm supposed to multiply it by a half, then d theta of sine 2 theta. When I differentiate this one, it gives me this, but times a half then will give me the numerator. I hope it is making sense, okay? Out of, then the sine of 2 theta, then the theta. Now, from here, if I take this a quarter outside, you will see that what is up here is the exact derivative of what is down here, just like here. So we shall have natural log of the denominator. But in the exam, we don't need all of this. I'm just doing it to help some people here. But right from here, we just expect the answer here, like what, a quarter, then natural log of 4x plus 3. We don't need all of this garbage I've written here. We don't need it. Then this one is equal to, then we have a half here, and then the natural log of sine of 2 theta. Then we shall put a c, because when you differentiate a constant, it disappears, right? Okay, now what we have gotten here is what we call the general solution. We have to use the these initial conditions here to get the value of c. Then we get what we call a particular solution. So when x is equal to 0, then theta is equal to pi over 12. Now when you put a 0 here, we shall get a quarter, then natural log of 3, which is equal to a half, then natural log of sine of 2 pi over 12, okay? Then plus c. So this is a quarter, natural log of 3, then minus, this is a half, This will be pi over 6, not so. Sine of pi over 6 is actually a half. So we shall have natural log of a half. That one will be equal to c. Now, this a half here is actually 2 to the power of negative 1, not so? That means that c is going to be equal to a quarter natural log of 3. Then when this negative 1 comes down here using rules of logarithms, the negative will make this one a positive because it will multiply with it. So plus a half, then natural log of what? Of 2. So meaning that our particular solution is this one here. So we have this one here, but then I'll take away this, and then I write this value that I've gotten here. So plus that. That is our particular solution. But they want us to obtain an expression in x, obtain an expression for x in terms of what? Theta. So we make this one here the subject. We make x the subject. Not so? Now we can multiply. I can begin by multiplying all through by 4. So here I'll have natural log of 4x plus 3. Then here I will have a 2, then natural log of sine of 2 theta. Then here I will have natural log of 3. And here I will have 2 natural log of 2. You see that? These ones here, I can put them on one side. Okay? I can simplify the natural logarithms and then I eliminate it. So this one, take the 2 here. If I take the 2 there, then it will be sine 2 theta, then squared, then plus the natural log of 3, then plus the natural log of 2 squared. You also take that one there. And then we shall have natural log of 4x here plus 3. Then this is all addition, so I multiply those powers. So we shall have natural log of now 3 times the 2 squared, which is a 4, then times sine squared 2 what? Theta. Okay? And now we can see a logarithm equated to a logarithm. That means the powers are equal. So therefore 4x plus 3 has to be equal to, this one is 12 sine squared 2 theta. So 4x here then shall be equal to 12 sine squared 2 theta. We subtract a 3. And then finally, our x is going to be, when you divide all through by 4, this one here can be 12 over 4, you get a 3, not so? So 3, then sine squared 2 theta, then minus 3 out of what? 4. As simple as that. Question 9 is coming from vectors with respect to the origin, or the points A, B, and C have position vectors given by this. Find a vector equation for the line through A and B. I've always shown this one, that suppose this is the road, okay, and this is your home here, your origin, okay, and here you join this road from your home, but then there is somewhere you know that distance, maybe you pass through a shop somewhere, okay, and you pass via a shop and you know that point there, and then you continue with that road. So all the points you pass through the road, let me represent them by R. This is your B, this is your A. Now we want this one here, or R is R here, then maybe this one is B and this one is what? Is A. This road is going this side there. Now For us to get OR, okay, that one will be equal to OA. You from your home, then you join the road, and then you go to R. Also, so plus AR. But if you know this distance, any other point that is beyond this B here, its distance from A is going to be this distance AB times a certain scalar. Okay, let's say times 2, then the distance is twice. Let's say times 1.5 times whatever, so long as it is more than 1, because if it is less than 1, then that means what you're going to get is going to be within here. You get it? So actually what this one means is that the OA you are having here, we are going to get AR can be expressed in terms of what? AB. So I can put lambda, then AB. Actually, AB is parallel to AR. Parallel vectors are said to be so if they can be expressed as scalar multiples of each other. You see? So there is a scalar we are multiplying into the AB that we know to get the AR. You see that? All right. So how do we get AB? From here, AB is going to be AO, then plus OB. But this one is positive because it is going in the same direction as this one here. This one is going to be negative because it is moving in the opposite what? Direction. So you have negative OA, then plus the OB. But what I usually say is get the last, then minus the first, as simple as that. Okay? So the last here is B. Then I will say OB minus the first is A. Then I will say minus what? OA. You see that? All right. So our OB is negative 213. Then our OA is 1, negative 4, 2. Now, negative 2 minus 1, that will be a negative 3. 1 minus minus 4, that one will be a positive 5. And then 3 minus 2, that one will be a 1. Just like that. Okay? After getting that, that means R here is going to be equal to, what is our OA? 1, negative 4, 2. Then plus lambda, and then we have negative 3, 5, 1. As simple as that. Then part B, using a scalar product, find the exact value of cos of the angle BAC. Okay? Angle BAC. So what we can do, this is the one here. You have B, you have A, you have C. Now what we always do, you either go in or spread out. What do I mean? You can use BA and then CA, or you can say AB and then AC. Okay, those are the ones we want. So you open up or you close in. So we need AB, that one we have it. Now how about AC? So AC here is going to be OC minus OA. What is OC? OC was given as 235, and then we subtract OA, which is 1, negative 4, 2. Now, this one gives us 2 minus 1, that's a 1, 3 minus minus 4, that's a 7, 5 minus 2, that is a 3. Now, we shall get AB, then we dot it with AC, then we get the modulus of AB, then times the modulus of AC. This is the definition of the scalar product. Then cosine of that angle BAC. Okay. So meaning cos of angle BAC, it is going to be AB dotted to AC. Then we divide by. It's like getting there. We call them what? It's like getting their unit vectors, because a unit vector, you get the vector then divide by its modulus. You multiply their unit vectors. So AB, dot it with SC. What do we have? So what is our AB? Is negative 3. Negative 3 here. Then 5, 1. We are dotting it with SC, which is 173. We are dividing by negative 3 squared plus 5 squared plus 1 squared times this other one is 1 squared plus 7 squared plus 3 squared. All right. Now, scalar product, you have negative 3 times 1, then 5 times 7, then 1 times 3. Then divide by, what do we have here? 9 plus 25, that is 34 plus 1, 35. And then here, 49, 59. 59. So, this implies that what we have here, 35 minus 3, that is 32, then plus 3, that is 35, not so. We have 35 out of root of 35, then times root of 59. Now, this is 35 to the power of 1, then out of 35 to the power of a half. This one simply implies that you have 35 power 1, then minus a half, which is 35 power what? A half. So we are having root of 35 over root of 59. So cosine of that angle BSC is going to be equal to root of 35 out of 59. So that is that. Hence, find the exact area of the triangle ABC. So if I have that triangle here, maybe it is like that, A, B, C. I need this angle. If I have this length and I have this length and then the angle in between, then I can get the area of the triangle. So area of triangle ABC then shall be equal to a half times AB times AC, then sine of the angle in between. Now, remember, sine theta is equal to sine squared theta plus cos squared theta is equal to 1. So meaning sine theta shall be equal to 1 minus cos squared theta under the square root. Not so? So this will be the square root of 1 minus, remember the other one we had 35 over 59 under the square root, then we can square this. So then we can have inside here 1 minus 35 over 59. That is 24 over 59. So square root of 24 over 59. So meaning area of our triangle is going to be a half times, what did we get as AB? AB, we got it as root of 35. So root of 35. And then SC is root of 59. Then sine of theta is here. It is root of 24 out of root of 59. Not so? Now root of 59 can cancel with that. And then we shall have a half times root of 35 times root of 24. So simplified, 0.5 times root of 35, then times root of 24. That is root of 210. As simple as that. And they said exact, so leave it like that. Question 10. is coming from polynomials, but find the quotient and the remainder when x squared is divided by 1 plus 4x squared. Now, if they give us long division here at first, then that means we are supposed to be using it in the next question. So this is 1 plus 4x squared. I can write it as 4x squared plus 1. So divide the first with the first, all right? So x squared divide by 4x squared. Then this one goes, we get a quarter, not so? So we shall put a quarter up here. Now, the rest we multiply. So when we multiply, we shall get that, and then plus 1 times a quarter, you will get what? A quarter. You see that? Then we subtract, and then we shall get, there is a 0 here. You see that? Then minus a quarter, then we shall get what? We shall get negative a quarter. So meaning our quotient is equal to a quarter, and then the remainder shall be equal to negative what? A quarter. As simple as that. Then part B, find the exact value of the integral from 0 to 0.5 x, then the arctan of 2x. Now, this is a product of two functions which are different. So here we use integration by parts. But when we are using integration by parts, we use this acronym ILET. One function has to be differentiated, the other function has to be integrated. This I here means inverse, okay? Inverse, trigonometric function. L here is for logarithmic functions. Then A here represents algebraic functions. And then T here, okay, represents trigonometric functions. And by the way, this is different. Trigonometric functions are different from inverse, okay? Then this one here is for exponential functions. Okay, now the one that comes before the other is the one we differentiate. So this is algebraic and this is inverse. So that means we are on this one and this one here. So inverse comes before algebraic, so we are supposed to differentiate the inverse one, okay? So u is going to be equal to the arctan of 2x. Take the tan this other side, it will be tan u, which is equal to 2x. When I differentiate this with respect to u, I will get sec squared, right? So now I'm differentiating everything with respect to x. I will get sec squared u, then du dx. Then when I differentiate this one with respect to x, I will get what? A 2. You get that? So remember, I need du dx. So du dx is going to be equal to 2 over sec squared u. Do you see that? Then after that, I can actually have this one here as 2 out of sec squared is the same as 1 plus tan squared, okay? And then we shall have 2 out of 1 plus, what do you see here? What do you see here? Tan u is 2x. Now this is tan squared. So we shall have 2x and then we square it, which will give us 2 out of 1 plus 4x squared. Okay? All right. Let me just put this one here. then there, and then there. Then the other function we are supposed to integrate, we call it dv dx, which is going to be equal to x. That means v is the integral of x with respect to x, which is going to be x squared over 2. I don't need to put this plus c because I won't need it in my what? Expression for integration by parts. So using integration by parts, when we integrate u, then we have here dv dx with respect to x. This one is going to be equal to uv minus the integral v, then du dx with respect to x here, okay? That means that when I'm integrating x, then the arctan of 2x here with respect to x, I will get our u is this arctan. Are we there? Arctan of 2x. Then our v is the x squared over 2. So when I multiply, I will put this one here first. Because when I put it here, x squared over 2, some people can interfere with this. And yet these are two different what? Functions. So it's better to write this one here. Okay? So we shall have our x squared over 2 written there. Then minus, we have v. Our v is x squared over 2. Then our du dx, we saw it is 2 out of 1 plus 4x what? Squared. We are integrating this. Now, of course, this one will disappear. That means we shall have x squared over 2, and then the arctan of 2x here. You get it? Then minus, and by the way, is it from 0 to... It is from 0 to 0 0.5. So 0 to 0 0.5. That means I can close this one up. And then I put 0 0.5 here, and then the 0. Same here. So here I'll have x squared out of 1 plus the 4x squared. Okay. Now, when we are integrating such an expression, the power of x here, or the degree of x, the degree of the numerator is equal to the degree of the denominator. So if the degree of the numerator is greater or equal to the degree of the denominator, we first long divide to convert that improper fraction into a proper fraction. You see, that is what they gave us first here to do, to first divide. I told you there is a way we are supposed to apply this one into the next. Okay, so we have the quotient is a quarter, and then the remainder is negative a quarter. So I'll come to this one, and then I write x squared over 2, then the arctan of 2x minus, now we are integrating, I'll put a quarter, the quotient, then the remainder is negative a quarter, so I'll put minus, then a quarter out of this 1 plus 4x squared, like that. 0 0.5, then 0, then like that. Then we have x squared out of 2, and then the arctan of 2x here. Now, of course, when you integrate this one, you will get 1 over 4 of x, right? Now here, when we differentiate our, let me put this one down. When we differentiate with respect to x, our 1 plus 4x squared, we cannot get, here we get 8x, but here there is no x. You get it? So here we don't use the natural logarithm. We get a natural logarithm if, for example, there is an x there, because what we have gotten here can be converted to what is there. You get it? All right. Now, what we are going to do here, For such, if there is a constant here and then there is something plus x squared down here, we use an arctan. So from the integral of 1 over a squared plus x squared, okay, this one giving us 1 over, it is given in the list of formulae, arctan of x over a, okay, this one here is going to be, let's check it out. We are going to have a quarter here, put a quarter outside. The integral of 1 over 1 plus 4 x squared here is going to be, we have to factorize. Remember, we need x here, the coefficient of x has to be a 1, right? So we have 1, then out of, pull out a 4. Then you will have here a quarter, then plus what? X squared, not so. Here, when you open brackets here, you will come back to this. Now, after that, I can pull out this 4, and then I say it is a quarter, then the integral of 1 over, a quarter is the same as a half squared, not so. Now, do you see that this one here is in the same format? Let me try to bring this one a little bit closer this way. So this one will be a quarter, then times, this is a half, not so? Our a is a half. So based on what we are having here, we shall have 1 over, our a is a half, then the arctan of x over a half. Then this one will give us a quarter, somersault this one times 2. So that one will give us a half, not so? So the whole thing here, we shall get a half, then the arctan of, even this one will somersault, and then we get 2 of x here. All right. Now, from here, I can actually take this one now down and say, therefore, the integral of this one here shall be, put it here, so it shall be this one here. Now, we said minus, we went to this one here, actually here, there is this a quarter here. I left this minus a quarter out. I just pulled out 1 over this. You remember? So there is that a quarter there. I will say minus a quarter, then times the integral of this one we have seen is this. So we shall say times a half, then the arctan of 2x. Okay, like that. And then we can put our limits, the 0.5 and the 0. Okay, let's put the limits, 0.5, then square it over 2, then the arctan of 2, of 2, then times the 0.5 minus, this is a quarter of x, which is 0.5, then plus, because the minus and the minus, then plus 1 over 8, then arctan of 2 times the 0.5. Now this whole thing here, that is when we put 0.5, and then when we put 0, this will be 0, 0 here. Arctan of 0 is also 0. So I'll just say minus 0. Now, 0.5 squared, that is a quarter, then divide by 2, that will be 1 over 8. Also, that will be 1 over 8. And then arctan of 1, that will be pi over 4. So when you write pi, actually here you give, you write your answer in radians. Don't write 45 degrees. You write pi over 4. And then here, this one is a quarter, then times a half is still 1 over 8. So 1 over 8. And then plus, this is 1 over 8 again, times, this is pi over 4, not so? And times pi over 4. Now, this and this are the same. So we have 2 times pi over 32. No, yes. Then minus 1 over 8. So this one will be a 16. So we shall have pi over 16 because 2 goes into here 16 times. Then minus 1 over 8. This becomes our answer, the exact one they told us to find. Question 11, I can see the first part is coming from differentiation. The diagram shows the graph of y is equal to 5 sine 2x cos squared x for x ranging from 0 to pi over 2, and its maximum point, m. That is the stationary point. And you know for stationary points, the y dx is equal to what? 0. Then part A, find the exact x coordinate of m. Okay, so we need to differentiate here our dy dx. And since this is a product of two functions, then we are going to use product rule. I'll keep 5 sine 2x constant. Then I'll differentiate with respect to x the cos squared of x. Cos squared of x is the same as saying cos x, then what? Squared. Then plus, I'll now keep 5 cos squared x constant. Then I will differentiate sine 2 of x. Here we are using what? Product rule. Then after that, so let's now begin to differentiate. This is 5 sine of 2x, then times. This one will drop down. So you will have 2, then cosine of x when you reduce the power by 1. Then enter inside and differentiate. Here you will get a negative what? Sine of x. That is chain rule, okay? Then I come to this one here. It will be 5 cos squared of x. When I differentiate this one here, it will give me cos of 2x, but then I will have to enter inside here and differentiate that angle. I will get a 2. So that is that. Then I will equate to what? To 0. So this will be negative 10, and then sine 2x cos x, then sine what? Sine x. Okay, and then from there, then plus again 10 here, 5 times 2, then cos 2x, then cos squared x, which is equal to 0. So I can turn these ones into tans, okay? Divide all through by, what can I do to make this one a tan? That will be cos 2x, not so? If that is cos 2x, then how can I make this one a tan? I have to divide by cos x such that this one goes, and then another cos x such that this one becomes a tan, not so? So that is cos squared x. Cos squared x. You can see that it is also here. That one can go, and then this one can go. But we can see that a 10 is also common. So that means here I'll have negative 10 sine 2x cos x, and because this is a sine x, we are dividing by 10 cos 2x cos x, then cos x, not so? Then plus, we have 10 cos 2x, then cos squared of x, then you divide this by 10 cos 2x, then cos squared of x. Now, Here we are getting negative tan 2x. That is coming from here. Okay. Then this cos goes. Then here we are having a tan x. And then here, of course, it is a 1, which is equal to what? To 0. Now, if I take this one this side, we shall have 1, which is equal to tan 2x tan x. 1 is equal to tan 2x is 2 tan x out of 1 minus tan squared x. Then we multiply by tan x here. Then we can cross multiply. We get 1 minus tan squared x, which is equal to 2 tan squared x. You see that? Then taking this one this side, it will become 3 tan squared x, which is equal to 1. Divide all through by 3. Tan squared x is equal to a third. Take the square root, then tan x is equal to plus or minus the square root of 1 over 3, which can be taken as 1 over root of 3. Now here, when you look at this, the x coordinate we are supposed to get is less than the 90. That is in the first quadrant. You see that? So if it is in the first quadrant where tan is positive, then I'm going to take the positive part. So what I'm going to have here, our x is going to be the arctan of 1 over root of 3. And this one gives you pi over 6, which is the 30 degrees, right? Pi over 6. But you give it in what? In radians. Then part B, by using the substitution u is equal to cosine of x, find the area of the region bounded by the curve, the x-axis between x is equal to 0 and pi over 4, and the line also this x is equal to pi over 4. Okay, this is integration by substitution. So if u is equal to cosine of x, then that means we need to convert the dx, then we put it in terms of what? Du. So du dx is going to be equal to negative sine of x. Okay, so meaning dx shall be equal to negative du out of sine x. Okay, so when they say between x is equal to 0, that is the y-axis, and then these are the limits, so pi over 4. Now that means the area is going to be, we are integrating from 0 to pi over 4. What is our y? Right from here is 5 sine 2x, 5 sine 2x, and then cos squared x, then with respect to x. Okay, now we can expand this. This is 5, then times, what is sine 2x? It is 2 sine x, then cos x, not so. But then there is a cos squared x here. So that means we are going to have the integral from 0 to pi over 4. This is a 10. I can put it outside here. Then here we have sine of x, then times the cos cubed of x, then dx. Now, our we need to get the values of u. Okay, we need to get those values of u when x, because here you can see that we are changing the limits. So if we are changing the limits, I think this one was left out. Let me bring it back here. Then we shall have, if x is equal to 0, then u is going to be cosine of 0, which gives us a 1. And then if x is equal to pi over 4, then u is going to be cos of pi over 4, which is 1 over root 2. Okay, or root 2 over 2, 1 over root 2. So implying When x is 0, we are having 1 here, and then this other one is going to be 1 over root of 2. Now, I'll have sine x here. Now, cos was given as u, so cos cubed, then will be u cubed. And then this dx is this one, negative du out of what? Sine x. You see that? That means if I take out that negative, it will be negative 10, then the integral of 1 over this one here. This sign will disappear, then we have u cubed, then du. Now, you should know that when I integrate from a to b, okay, a certain function, this one is the same as negative of b to a, okay, of f of x dx. That is if b is greater than what? A. So from the lower limit to the upper limit, that is what we are supposed to be integrating, okay? But now if you are integrating from the bigger one now to the smaller one, then that is the negative of this other one here. You get it? Now, this one here, first of all, is negative 10, then you integrate. This will be the negative of, because 1 is bigger than this, okay? Root 2 is 1.414. So 1 over 1.414, you are going to see a value which is less than what? 1. 1 divided by root of 2. Do you see that you get 0.7? So this one here is less than this. So I'm going to switch them. I'll put 1 over root of 2 here, then a 1 here, and then I include a negative. You see that? Based on what I've told you here. So this is u power 3, then du. Next, of course, this one is positive 10. Now we integrate. This will be u power 4 over 3. And then we put 1 and then 1 over root of 2. So this will be 10, then into 1. I made a mistake here. This one is supposed to be a 4. We are dividing by the new power. So 1 over 4, then minus. This will be 1 over root of 2. Then power it with a 4. Then we shall divide it by a 4. So here we shall get a 10 into a quarter. How about this one here? 1 out of root of 2. Then we power it with a 4. And then after that, we divide it by 4. So it gives us 1 over 16. Now altogether, what do we get here? 10 into 1 out of 4. Then minus 1 out of 16. 15 over 8. So the answer here is therefore 15 out of 8. That is that. So this has been it for this second part of the paper. Thank you so much for watching. May God bless. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.